Okay, let's quickly go through the first one. So state why each of these compounds is a hydrocarbon. Yes, anyone would like to tell the answer?
Because they have carbons and hydrogens only.
Correct, that's right. Okay, so hydrocarbons are compounds which have only hydrogen and carbon, right? So these are hydrocarbons. Perfect, very good. The next one, state why the formula given for D is called a full structural formula.
Because
Um,
it shows all of the hydrogen bonds.
Yeah.
Uh, See,
All of the
thing is,
carbon to carbon and hydrogen bonds.
okay, see, thing is, a full structural formula is a formula in which it shows all the atoms, including all the bonds as well. Okay, so you need not say like it hydrogen bonds or carbon to carbon bonds. You should say that it is a full structural formula because it shows all the atoms with the all the bonds. Okay, so that should be your answer. Okay, let's go to the next one. So give the letters that represent the four compounds with the general formula CnH2n plus 2. What will be answer for this one?
Alkanes.
Yes, alkanes, right? So CnH2n plus 2 is for alkanes. So which one are those? What will be the letters which represent alkanes?
Uh, mm, which ones are correct from the table?
Yes, correct. That's right. That's the question.
Um, CH4, C2H6, C3H8, and C4H10. I think that all follows the rules.
Yes, correct. That's the right answer. So A, C, D, F. By the way, have you printed this worksheet already or not yet?
Yes, I
We
have it
have it
printed.
on our laptop, yeah.
Okay, so like when we are discussing it, you can try to write the answers. Okay, next question is deduce the equation to show the complete combustion of propane. Yes, please try it out. So what is the formula of propane? Alex, can you tell me what is the formula of propane?
Is it C4H10?
Sarah, do you agree with that?
No, I think it's C3H8, like to show the full to show the full combustion reaction of propane.
Okay.
C3H8
Mhm.
plus O2, and then the products will be CO2 plus H2O.
Correct. Very good. Okay. Alex, thing is the general formula of alkanes is CnH2n plus 2, right? So propane is for three carbons, right? So it will be C3H8. Are you clear
Okay.
with this?
Yeah, thank you.
Okay, so just make a note of this. One is methane, two is ethane. You know it, no, you know the sequence, right?
Yes.
So one methane, two
Yeah.
ethane, three propane, four butane, five is pentane, six is hexane, seven is heptane, eight is octane, nine is nonane, and 10 is decane. So in case you remember till 10, that should be good enough for your exams. Okay. Yeah. So the products will be CO2 plus H2O. Very good. Now, can you take a minute to balance this equation and tell me the final answer? All of you can try it out.
Okay.
See, I expect that this question will come in exam, maybe not propane, but they can give you something else. But a balancing equation will definitely be there in the exam. So make sure that you practice this one.
I think oxygen, for the reactants, oxygen will have a 5 in front.
Okay.
And
Mhm.
then for the products for carbon dioxide, CO2, it will be 3.
Okay.
And
Mhm.
then H2O4, I'm
Mhm.
pretty sure.
So it'll be 4H2O, right?
Yeah, I think.
Correct. Very good. That's right. So this is Alex, right?
No,
Who said
Sarah.
that? Oh, Sarah. Okay. So I'm like, I'm not able to see who spoke. Yeah. So Sarah, good. Okay, Alex and Laura, are you clear with like how we went about balancing this equation?
Yeah, I got the same answer as Sarah.
Okay, that's wonderful. Wonderful. Okay, so can we go to the next question if you're clear with this?
Yes, that's
Yeah.
fine.
Okay. Okay, then when shale gas is burnt, the hydrogen sulfide reacts with oxygen. Describe how the combustion of shale gas can lead to formation of acid rain. Okay, so who wants to answer this one?
I wasn't too sure with this one, Miss.
Yeah, me too.
Okay,
I was
sure.
So maybe we can consider.
Yeah, we'll discuss it. Anybody else wants to try it out?
Wouldn't it be something to do with sulfuric acid being formed?
Okay, that's right. That's correct. Okay, very good. Okay, so basically what happens is you can see in this reaction, sulfur dioxide is formed, right? Now what happens is this sulfur dioxide, it reacts with more oxygen, it forms sulfur trioxide. Okay, please make a note of this answer. So sulfur dioxide is formed in this reaction. It reacts with more oxygen, it forms sulfur trioxide. Okay, now what happens is this sulfur trioxide, it reacts with the rainwater. Okay, so the sulfur trioxide is it's in gaseous form, it goes up and then it reacts with the rainwater. Okay, and then it forms the sulfuric acid. So that is H2SO4. Are you clear with this?
Yes.
Okay, so remember this sulfur dioxide is formed in this reaction. So this gas goes up in the atmosphere, reacts with more oxygen, it forms sulfur trioxide. Now this sulfur trioxide reacts with more water, like the rainwater basically, and it forms sulfuric acid. Now this comes down on earth as acid rain. Are you clear with this? So can you tell me what are the ill effects of acid rain? What are the disadvantages or what are the ill effects of acid rain on earth, on living organisms?
They can cause ocean acidity
Mm-hmm.
towards the pH level. They can
Mm-hmm.
also, I think, for like certain statues, they can cause them to like decay or
Correct, that's right. Anything else? Do you want to add anything else? Okay. See, acid rain, like in case it falls on organisms, for example, animals or human beings, it can cause skin allergies as well, right? And apart from that, when it falls into the water bodies, it can really decrease the pH level. So what happens is many organisms die. And when they die, it can affect the food chains and the food web. Clear?
Yeah.
Are you clear with this or no? Any doubts here?
Yes, it makes sense.
Okay, so in case this question comes in exam, it says describe how the combustion of shale gas can lead to formation of acid rain. What you will be writing is in this reaction, sulfur dioxide is formed, which reacts with more oxygen and forms sulfur trioxide. Now, this sulfur trioxide in the atmosphere combines with rainwater and forms sulfuric acid, which comes down in the form of acid. Right? Like this forms acid rain. Okay, so and if you want, you can write these reactions. These reactions will be useful. Do you have any doubts or you're clear with how to answer this question?
yeah, all good.
All good, right? Okay, let's go to the next one. Next question is the table below summarizes the physical properties of two fractions from crude oil. Explain in terms of their structure the differences in physical properties of gasoline and fuel oil. Anyone wants to try this one out? So this is level 7 to 8. So please try it out. Sarah, do you want to try it out?
Yeah, I'm still thinking on this one.
Okay, Laura and Alex.
So we can see that gasoline burns at a lower temperature than fossil oil, fuel oil, sorry.
Oil, right?
And we can also see that gasoline is more flammable than fuel oil.
Mm-hmm.
And we can see that they have different colors because gasoline is a yellow while fuel oil is a dark brown.
Correct. Okay.
And it can be assumed that fuel oil is more viscous and less volatile, and it has a longer chain.
Ah, yes. Okay. So, see, please read the question carefully. What does it say? It says explain in terms of their structure. Okay, so what you said just now is like describing whatever is already given here. Understand? So you have to explain in terms of their structure. So structure is the main part, like the you will get the marks based on what you write about the structure. Okay, so yeah, now I want to describe the structure of these two mixtures. So gasoline and fuel oil, how they are different in terms of their structure. Any idea? Like what is gasoline made up of? What is fuel oil made up of? Okay, you can quickly do a Google search and tell me how many carbon atom, like carbon chain atoms are there in gasoline and fuel oil. Okay, let me do it. Let me do it quickly. So,
So isn't
oh, there
it
are more people
since
joining. Okay, Abdullah, Yuvan, hi. Andrej, hi. How are you doing? All of you good?
Our goodness.
Yes,
Okay,
yes.
that's wonderful. Welcome to the workshop, and I hope that it will be very useful for you all. Okay, so yeah, we are working on the question regarding the fractional distillation of petroleum. Okay, so we are like looking at difference between gasoline and fuel oil. So fractional distillation. Okay, so make a note of this. I expect a question from this part as well. Okay, so let us have a look at fractional distillation. Okay, yes. Okay, so can you tell me what is the difference between gasoline and fuel oil as far as the number of carbon atoms are concerned? Yes.
Fuel oil has 20 to 70 carbons, while gasoline has 5 to 10 carbons.
Very good. That's right. Okay, so this has to form a main part of your answer. Okay, let me just, okay. Yeah. Okay, so that has to form a very, very main part of your answer. So let me go back to the worksheet. Yes. Okay, so what you should be writing is, so gasoline, it contains, like it has carbon chain from C5 to C10, whereas fuel oil, it consists of carbon chains from C20 to C70. Okay, so now this is the major difference between these two. Because of this difference, it has these properties. Okay, now tell me, when you increase the number of atoms in a molecule, why does the boiling point increase? What is the reason the boiling point should increase?
because it takes
There's
long. I'm
more
sorry.
chains to that are needed to be broken down because the
Mhm.
molecular attraction is stronger.
Very good. Well done. That's right. Okay. So in case you have more number of atoms, what happens is the intermolecular forces are stronger. So to break them, you require more energy. So the boiling point will be increased, right? Very good. Okay. Then flammability. Yes. In case the chain is short length, it will be highly flammable, right? So in this case, gasoline will be highly flammable. And as you increase the chain size, the color becomes more and more darker. So it will be fuel oil is dark brown, whereas gasoline is yellow. Understand this? So when you're answering this question, you start by telling the number of carbon atoms in these two compounds, like these two mixtures. This will give you a lot of marks here, and then you explain with the increasing number of carbon atoms, what happens is the intermolecular force of attraction increases, so you require more amount of heat to break them. That's why the boiling point is high. And similarly for flammability and color. Any doubts here? Any doubts here, or can we go to the next question?
Just one thing. What's the difference between like why one is highly flammable and the other is just flammable?
Okay, see, thing is, in case you have lower number of atoms, they catch fire easily. Like most of them are in gaseous state. If you see like the lower compounds, like these are in gaseous state. So gases, they can easily catch fire. So when we say it is highly flammable, flammable means it can easily catch fire. So the mixtures which have more content of gases will be very easy to catch fire. That's why gasoline will be highly like it can easily catch fire. It will be highly flammable.
Okay, thank you.
Okay. Okay, so this is fine. Can we go to the next one? Anyone, any doubts here?
No, it's fine.
Yeah,
Okay. Okay, let's go to the next one. Now, next is okay. So please remember this. Like I have got two papers, and both of them have questions on fractional distillation. So I assume that one question definitely is coming from fractional distillation. So to like you make sure that you go through this, remember the number of carbon atoms in each one of them and their uses as well. Because in another paper there is a question on usage of the different components. So please make sure that you remember that. Okay, let's go to the next one. So next question is about solubility rules. So do you remember the solubility rules or no?
No, they told us that we would have the table, which
Oh,
tells us
okay.
which things are
Oh,
soluble.
okay, okay. What about this one? Will you have the table with you for the fractional distillation thing or you have to remember?
I
No, I
think we have
think
to
we're
remember.
Come again?
Right, Laura? I think we have to remember.
Oh,
yeah,
okay, you have to remember, right?
that's
Okay,
right.
you have to remember. Yeah, so make sure that you remember it because one question is definitely coming from there. Okay, so this will be easy then in case you have the table in front of you, that becomes very easy. So, okay, Abdullah, can you tell me ammonium chloride, whether it is soluble or insoluble? You can look at the, okay, do you have the chart with you or no? Okay, let me open
Not
the
with me, miss.
solubility
I'm
chart.
looking for it.
Oh, you're looking at it? Okay, yeah. So I can open the solubility chart and then we can quickly go through that. Okay, so yeah.
It is soluble, miss.
Yes, correct. Very good. Okay, so it is soluble. So so it is ammonium chloride. So all ammonium salts are soluble, right? So you can see here group 1A cations and ammonium salts, they are all soluble. So there is no exception. So first one is soluble. Very good. Next one is lithium sulfate. So what do you think? Lithium sulfate. Alex, can you tell me? So lithium sulfate, whether it is soluble or insoluble?
Sorry, it's soluble.
Very good. Okay, so you can see here, all sulfates are soluble except these ones. So exceptions are strontium, barium, mercury, and lead, right? So lithium sulfate is soluble definitely. Okay, then we go to magnesium carbonate. So magnesium carbonate, is it soluble or insoluble? Laura,
Insoluble?
can you answer?
Yeah, insoluble.
Insoluble, right? Why? So all carbonates are insoluble except group 1A and NH4 plus. Okay, so all carbonates are insoluble except the group 1A cations and ammonium carbonate, right? So here they have given magnesium carbonate, which belongs to group 2. That's why it will be insoluble, right? Okay, correct. Very good. So we are done with this. So this is soluble. Let me write it here. So this is soluble, then this is insoluble. Okay, till here, everyone is following, everyone is up to the mark, like you follow this one, right? Everyone, are you on the same
Yes.
page?
Yep.
Yes.
Yes.
Okay, good, well done. Let's go to the next one. Next question. Okay. Okay, I want one of you to read this for me, please. Anyone can volunteer to read the question for me? Yes.
I'll go, miss.
Okay, very good. Who is this? Let me just check who is
It's me,
this.
Andre, miss.
Okay, that's good. Thank you so much. Let me show the screen. Okay. Yes, please go ahead.
Okay, so a metal is added to a copper sulfate solution. A displacement reaction only occurs if the metal is added to is if the metal added is more reactive than copper. And there's the equation there. And displacement reactions are exothermic. The more reactive the metal added, the greater the temperature rise. A student uses the following method in an experiment to compare the reactivities of different metals. Pour some copper sulfate solution into a boiling tube and record its temperature using a thermometer. Add some metal to the tube and stir with the thermometer and record the maximum temperature of the contents of the tube. He repeats the method using the same amount in moles of different metals. So for Shand 2 we have to make the experiment valid, he starts with the copper sulfate solution and then added metal to at the same temperature. State two other variables that must be controlled if the experiment is to be valid.
Okay. Everyone, do you follow this experiment or no? Anyone who is not able to follow this experiment, please let me know. See, you can be frank. Nobody is judging you. We are all here to learn. So if you do not understand this experiment, please let me know. Okay, if you are following, say yes.
Yes.
If you follow this experiment, say yes. If you don't say yes, I
Yes.
assume that you don't understand. Do you follow this experiment?
Yes.
Yes. Okay, good. Okay, so let's go to the first part. So it says state two other variables that must be controlled if the experiment is to be valid. Okay, so we have got around 9 to 10 people here. So I'm looking for at least 3 variables you want to keep control. So maybe like you can discuss among yourselves and tell me. Do you want to discuss among yourself and maybe tell me like any 3 variables which you want to control? Yes. Okay, maybe take 30 seconds, think about it, and then maybe put in the chat. Uh, can you put in the chat like what variables you want to keep it controlled?
The volume, like the
Uh-huh.
amount.
Yes, the volume of the copper sulfate, right?
Yes, and also the
got it.
mass of the metal, like how much metal you put in.
Yes, I think that is already controlled, right? Because they have taken the same number of moles.
Yeah.
Okay, then what else? So that you cannot put it here because they have said that he repeats the method using the same amount in moles of different metals. So that point you can't put it here because it's already controlled, right? So you have to put any other control. Yeah, what else should we? What are the other things we can put it here? So correct. So one is volume of copper sulfate. What else?
Like the time that is taken to record, I think.
Okay. Can you explain me what do you mean by time to take record? Like, yeah, I mean, like, I think, yeah, that can be one of them, but I want you to explain me what do you want to say about that? Hmm?
Like, when the temperature is recorded to make sure the time intervals are the same, so then so that the temperature can't go down and decrease, so it's
Yes.
like the same amount of time every time.
Correct. Very good. That's a good point actually. Yeah. So time duration for each set. That is also one point you can put. So time duration for each set. Okay. Then what else? What else can you put? What about presence or absence of catalyst? Do you agree with me or no? So presence or absence of catalyst, will it affect the reaction rate or no?
Yeah, because if there's a catalyst, it will either speed up the reaction or
That's right. Okay, so for every reaction, in case you are doing with a catalyst, do for like all of them, you should do with a catalyst. In case you are doing without, then you should do without. Okay, then what else? Any other thing you want to contribute here? Like any other point you want to add?
maybe well, it kind of already said the boiling tube, but like the equipment being used. It's so
Right,
that it's
right.
the same.
Yes, okay. Uh-huh. So it can be surface area. So when we say boiling tube, so it can be correlated to surface area as well, right? So you keep the surface area same, right?
Yeah.
Understand this? So they have asked you 2 variables. So you can put volume of copper sulfate. You can also put amount of the amount of metal, but it is already given here. So I will say that don't put this point. But yes, in case this sentence was not given here, you can obviously like put that same amount of moles of metal should be taken. Okay, so remember this. In case this sentence was not given here, you can also put that take same number of moles of the metal, right? So volume of copper sulfate is one thing, then take same amount of moles of metal, that's the second thing. Then time duration for each set measurement, that is the third thing. Then presence or absence of catalyst, that's the fourth thing. And the surface area for experiment, that is the fifth thing. Are you clear with this? You can put any 2 points from here. Are you clear with this or no?
Yes.
Yes.
Okay, well done. Let's go to the next one. Okay, so it's strand 2, level 3 to 4. Okay, so I want one more volunteer to read this question for me. Yes.
Another student uses the same method 3 times for each of the metals, E, F, G, and H. The table shows her results for these metals. The student calculates the mean temperature increases for metals E and F. She does not include anomalous values in her calculations. Calculate the mean temperature increase for metals G and H, ignoring any anomalous values. Write your answers in the table.
Thank you. Thank you very much. Okay. Now, what are anomalous values? Anomalous values are which are like outliers, which do not match with the other data. Okay. So, for example, in the E part, first reading is 7, second reading is 4, third reading is 8. Okay. So, in this case, 4 will be an outlier. So, this is called as an anomalous value. Okay. So, remember this. What is an anomalous value? The value which does not match with the other data. Okay. So in this case, it will be 4. So how we have taken the mean? We have done 7 plus 8 divided by 2, that is 7.5. Everyone understands this?
Yes.
Okay, good. Okay, now I want you to try out G and tell me the answer. All of you, please try it out and then tell me the answer. So for the G reading, what will be the mean temperature? Remember this, you
It's
have to. Mhm.
sorry, it's 5.46.
Okay, yes, that's right. 5.46. Okay, so can you explain us how did you get the number?
So I did 6 plus 5 plus 5.4, and
Mhm.
then I divided it all by 3.
Correct, very good. Okay, so we can see that there is no outlier or anomalous reading in this. Okay, so 5.456, they're like close by, right? So that's why there is no anomalous reading here. So we take three of them, add them up, and then divide by 3 to get the mean temperature. Okay, good. Okay, let's go to H. So please everyone try it out and tell me the right answer. Anyone done? Let me know.
Yeah, so
11.5.
Come again.
It's 11.5.
Very good, 11.5, right? Why? Because here 5.5 is an anomalous reading, right? So it's an outlier. So we have to take 11 and 12. So 11 plus 12 divided by 2 will be 11.5. Okay, good. Okay, let's go to the next question. So next part is explain which metal is the most reactive. Okay, so we have seen that where there is a reaction, uh, it will show a like higher increase in the temperature. So it says which explain which metal is the most reactive. So can anyone tell me which metal is the most reactive?
I would say E because the temperature increased the most in each interval.
Mm,
H.
mm-hmm. So okay, you say E or H?
H.
Okay. Anybody with a different view? Okay. See, the answer is H. Okay, H is correct. So can you justify why H is correct? Yes,
because
why H
more,
is correct?
sorry, because more reactive, the metals that are more reactive have a
Mhm.
higher temperature, like the
Correct.
melting
That's
temperature.
right. Okay, so it says you can see that in H there is a highest increase in the mean temperature. That's why H will be the most reactive element or metal. Clear? So you can write that in H we can see the highest increase in the mean temperature. That's why H will be the most reactive metal. Okay, so that's correct. Let's go to the next one. Explain which metal is less reactive than copper. Yes. So which one is the one which is less reactive than copper? Yes. Anybody wants to answer this one?
Would it be F?
Correct. Very good. Can you explain why?
Because copper barely reacts and F had no reaction.
Yes. Okay. So how do you know this? Because there is there is no change in the mean temperature. Clear with that? So depending on these numbers only, we have to answer this one. So you can see that in case of F, there is no change in the mean temperature. That's why copper is less reactive than uh, F is less reactive than copper. Are you clear with this? So because
Yes.
temperature will
Yeah.
only increase when there is a reaction, and reaction will be there only if there is a metal which is more reactive than copper. Since in case of F, there is no increase in temperature, it means that that metal is less reactive than copper. Is everyone clear or no?
Yes.
Okay, let's go to the next one. Okay, now strand 7, level 7 to 8. Okay, let's try to first understand this question. So it says metal H could be magnesium. Explain why the reaction between magnesium and copper to sulfate can be described as a redox reaction. Okay, so Alex, Sarah, and Laura were the first ones to join, and they said that they want to practice more of level 7 to 8. So there is this question is for them and others as well, obviously. So let's try to answer this one. First of all, can somebody, like any one of you, tell me the reaction for this equation? Yes. So what is the reaction for this one?
Magnesium sulfate and copper.
Okay, so you have got magnesium. No, it's not magnesium sulfate. It is magnesium and copper sulfate, right?
Yeah, wouldn't that be the product? Wouldn't the product
Yes,
be
yes. So let's write the reactants first. So magnesium plus copper sulfate, which is an aqueous state, forms what? Yeah, now tell me what will be the products?
magnesium sulfate and copper by itself?
Correct. Very good. That's right. Okay, so it will form magnesium sulfate plus copper, right? That's right. Okay, so it will form copper. So this will be, okay, this will be solid and this may be liquid. Okay, so now let me know, you know what are oxidation states, right? So this goes from, so what is the oxidation state of magnesium?
0 because it's by itself.
Correct, very good, that's right. Now, what is the oxidation state of copper in copper sulfate?
+2 because sulfate is -2.
Okay, so this is +2 and sulfate is -2, right? Correct, very good. Okay, what about this one? Magnesium is what?
Since sulfate is still -2, it should be +2.
Okay, so this will be +2 and then this is -2, like we know it's -2. And what about copper?
0 because it's by itself.
Correct, very good. Okay, so I think who was this answering? Like, is Sarah the one who was answering this?
It's me, Laura, sorry.
Oh, Laura, sorry. So yeah, okay, Laura, very good, well done. Okay, what about others? Because when I'm like I have this open, I cannot see who is speaking. So what about others? Are you clear with like how do we give off oxidation states to the different components here, or you're not clear? Please let me know because this is important. This question will come in exam, and I want that you should understand this. Are you clear with this or no?
Yes, miss. I
Yeah.
think we're clear.
Mhm. You're clear, right? Okay, remember this. So when we assign the oxidation states, anything which is an elemental state will have an oxidation state of 0. Okay, so elemental state is like in what form it is naturally found. Okay, so that will be 0. So magnesium solid will be 0, right? And then we have in compound. So depending on like I think you already would have studied before. So like different compounds, it will have different oxidation states. So it can have, so copper can have +1 or +2. So depending on what compound it is in, it will have that particular state. For example, sulfate is -2. So obviously copper will be +2. Okay, so here magnesium will get +2 and sulfate is -2, you already know, and copper will be 0 because it is an elemental state. So you can see here magnesium is going from, so in this reaction, magnesium is going from 0 to +2, right? So it is undergoing oxidation. So when there is increase in the oxidation state, it is oxidation, right? And you can see that copper, it is going from +2 to 0, right? So it is undergoing reduction. Are you clear with this? Is everyone
Yes.
clear or no?
Yep.
So you can see here, magnesium is oxidized from 0 to +2, whereas copper is reduced from +2 to 0. That's why this is a redox reaction. Anyone, any doubts here? Okay, so what is a redox reaction? Redox reaction is a reaction in which reduction and oxidation take place together. So in this case, one element, which is magnesium, it is going from 0 to +2. That's why it is oxidation. Copper is going from +2 to 0, that is reduction. So both the things, both the processes, oxidation, reduction, taking place together. That's why it is a redox reaction. Do you have any doubts, or like you're clear with this? I expect one question on this will definitely come. So please go through the table of oxidation numbers. Make sure that you do it very properly. Are you
I
clear
have
with
a
this?
question.
Yes, please.
So I knew that sulfate had a charge of -2, but in the case that I don't know what it is, what do I do? Like, how do I find it?
Okay, how do you find it, right? So you want to find it for which one? You want to
For
find the charge for which one? Okay, so
yeah.
there are rules for that. Okay, so CuSO4. See, thing is, there are rules for that. For example, oxygen is always -2. Okay, and copper, it can be +1 or +2. Okay, so there are like rules for that. Maybe I can share the rules quickly. Okay, I'll take a minute to find out that particular thing. Yeah, I think it makes sense to go through the rules. If you want, you can take a screenshot of that one. So there are rules for that, and if you want, you can try to remember that. Let me just open it.
Thank you so much. Sorry.
Yeah, no worries. Okay, so there are rules, and I think if you have a copy, it will be great. Let me just quickly go through the page numbers. That is. Mm, Yeah, this one 406. Okay, so like I request all of you to take a screenshot so that later if it comes in exam, like it's good to revise through it. I do not expect any complicated questions for at your level, but it's good to have a, like, maybe just remember that. Okay. Okay. Yes, you can take a screenshot for this one. Let me maximize it. Just a minute. Let me. Okay. Yeah, this is the one I want to take a screenshot of. Strategy for assigning oxidation states. Or you can take a picture on your phone, whatever is convenient for you. Once you're done, let me know.
I took the screenshot.
Okay, so I'll just quickly go through this one. So it says atoms in the free element have an oxidation state of 0. Okay, for example, magnesium, O2, N2, argon, they will have an oxidation state of 0. Okay, then in simple ions, the oxidation state is the same as the charge on the ion. Okay, for example, Mg will, like Mg2 plus will have a oxidation state of +2. Then O2 minus will be -2, and 3 minus will be -3. Okay, so like this part is very simple. So you can recognize what ion it is, and then you can get the oxidation number from there. Okay, then oxidation state of all the atoms in a neutral compound must add up to 0. Okay, so it means that in case you have a compound H2SO4, the sum of all oxidation states should be equal to 0. So it means that when we add up the oxidation state for hydrogen, sulfur, oxygen, it should all add up to 0. Are you clear with this?
Yeah, so in the case of hydrogen sulfate, what I would do if I didn't know what sulfate was, I
Mhm.
would find first the hydrogen alone. I would see what that was, and then I would try to find, and then I would just do the number that matches up to make 0, right?
Yes, correct. Okay, see, but hydrogen also, it is like most of the time it is +1. Oxygen, most of the times it is -2. Okay, so
Yes.
that you can, so that is like most of the cases it is set, but like sometimes it may have variable. So you can just check from there. Then in case, for example, oxidation state of all the atoms in a polyatomic ion must add up to the charge on the ion. For example, SO4 2 minus, the sum of oxidation state should be equal to -2. Clear with this? So can you quickly tell me in SO4 2 minus, what is the oxidation state of sulfur? Yes. So in SO4 2 minus, what is the oxidation state of sulfur?
0.
How did you get 0?
Miss, I got a question like this similar. In the test, it was like to find
Mhm.
the oxidation state of zinc oxide, and because zinc was by itself, it was 0. So I'm just gonna assume that sulfur in H2SO4 will be 0.
No, no, no. Okay, we will solve that one now. Okay, yeah. So, okay, just let me make a note of. So you got zinc sulfate, right? So the question was, what is the oxidation state of zinc and zinc sulfate, right?
Um, no. The question that I got in the test was like
Mhm.
zinc oxide, if you're talking about that.
Oh, zinc oxide or zinc sulfate?
Zinc oxide.
Oh, so what is the oxidation state of zinc and zinc oxide?
Yes.
Okay, correct. We'll discuss that. Okay, give me a minute. We'll finish this part and then we'll come to that your question. Okay. Yes. So the oxidation state of all the atoms in a polyatomic ion must add up to the charge on the ion. For example, SO4 2 minus, the sum of oxidation state is equal to -2. Okay. So in, suppose we assume that the oxidation state of sulfur is X. Now oxygen is -2 always, right? So it will be X plus 4 into -2 is equal to 2 minus. Do you agree with this calculation or no? Yes. See, so we have to find the oxidation state of sulfur in SO4 2 minus. How will you find? Okay, we'll solve this question as well. So SO4 2 minus oxidation states, we'll do that. Okay. So yeah, like we'll solve it. Like once I go to the whiteboard, I can solve it there. Then the usual oxidation state of for an element is same as the charge on its most common ion. Okay. So for example, hydrogen will be +1 always. Oxygen is -2 usually. Clear? Okay, so there are some elements which will have multiple oxidation states. Okay, so for example, nitrogen, phosphorus, sulfur, tin, lead, and all transition elements, they have multiple oxidation states. So depending on case by case, they can have multiple oxidation states. Okay, so we'll discuss the two examples just now we took it. Okay, let me just make a note of this as well. I don't think you will get a question from this because like for your level, I don't think they will be putting too much tough questions. But in case you just take a screenshot of this one, these are the like exceptions. Okay, so we have like discussed already, oxygen is -2 in most of the cases, but in H2O2 it is -1 and O of 2 it is +2. Have you taken the screenshot? Hello.
Yeah. So
Yes,
pretty
Okay.
much
yes.
if you're saying like these are like the generic ones we're gonna get, so like we should just know the usual
Yes, yes,
oxidation state, because
yes,
otherwise
that's
there's not really another way to find it unless we know the ions.
yes, that's right.
Okay.
Okay, so yeah, these are the exceptions. So at your level, I don't think they will be giving you the exceptions. Okay, so okay, now let's try to practice since you already have these questions. So I want to try them out. So all of you assign oxidation state to all the elements in H2SO4. Try it out. So I want you to take this question, assign oxidation states to all the elements in H2SO4. Please do it. Are you clear with the question? So you have to assign oxidation states to all the elements in H2SO4. Is anyone not clear with the question? Please let me know. See, if you don't answer, I assume that you all are clear. Are you clear or not clear?
Yes.
Okay. So the question is assign oxidation states to all the elements in H2SO4. So please try it out. We'll discuss. Are you done?
Yes, I think, Miss.
Okay. Anyone? Okay. Is everyone done?
Yes.
Yes.
Okay. So let's discuss. Okay. Let me just have a look like, okay. Yeah. Okay. So yes. So hydrogen, what is the oxidation state of hydrogen?
Positive
I
2.
think
Just two.
-2 and then
Okay, just a minute, just a minute. So you have got hydrogen, you have got sulfur, you have got oxygen. So hydrogen is, see, hydrogen we have seen it will have an oxidation state of +1, right?
Yes.
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 So it will be +1. Then oxygen, what is the normal state of oxygen?
-2.
-2, right? That's right. See, sulfur can have multiple oxidation states. So in this case, what will be the oxidation state?
+2.
Hmm.
+1.
Yes. So how do you calculate? Okay, let's try it out. So I'm sorry, I'm really having a bad throat. So, okay, so it will be 2 into +1 plus, suppose we assume that the oxidation state of sulfur is X. So this will be 2 into +1 plus X plus 4 into -2 is equal to 0. Do you understand this calculation or no?
Yes.
Anybody not clear with the calculation?
Yeah, miss, I don't understand.
Okay, so how we have done this one? So 2 into +1, because there are 2 atoms of hydrogen. So for one, like you have +1, so it will be 2 into +1. We have assumed that sulfur is X. See, sulfur can have multiple oxidation state. It depends on case by case, which compound you take. And then for oxygen, it is -2. So this will be 4 into -2, which is equal to, since there is no charge here, it will be equal to 0. Now it becomes very simple. You just have to do the calculation. So it will be 2 plus X minus 8 is equal to 0. Yeah, so what will be X?
6 plus 6.
Correct. +6. Very good. So 8 minus 2 is equal to +6. Very good. Is everyone clear? How do you get the answer for this one?
Yes.
Okay, let's go to the next one. Next one, I think somebody had a question on zinc oxide. So the question was, what is the oxidation state of zinc in zinc oxide? So yes, how do we do this? This is like very simple. Tell me, how do you do it?
So since the zinc is isolated, it will be 0 because it's by itself.
Mm-hmm. No, it is not by itself. It is in the form of a compound, right? It is not in by itself.
No, I know, but if you're trying to figure out just zinc, it will be by itself. So it will be 0 if it's just zinc. Because that's what the question was.
No, but the question was, what is the oxidation state of zinc in zinc oxide, right?
It's
Yes,
plus 2.
yes.
Yes or no? See, the question was, what is the oxidation state of zinc in zinc oxide? So basically, they're
Oh, yes,
asking you,
okay. Yeah, okay. That's my bad,
understand?
miss. I got confused.
Yeah. Okay, yeah, so yeah, see, in case they give you a compound, you have to take the whole compound, right? So the question is, what is the oxidation state of zinc in zinc oxide? So how do you try to answer this one? So let's assume that the oxidation state of zinc is X. So X plus oxygen is -2, right? Is equal to 0. So X will be equal to +2. So that is the answer. So the oxidation state of zinc is +2. Are you clear with this or no?
Yes, yes. I understand.
Everyone clear? See, so this is a very simple question. So I don't expect any too complicated questions in your exam. So this one, see, don't get confused by the words. Think when they say that zinc in zinc oxide. So they're not telling you zinc elemental form. It is in the compound form. So in a compound form, obviously it will not be 0. Understand this? Is everyone clear? Okay, let's try out
Yes.
one more question and then we can go to the next one. Okay, try out this one as well. So, okay, see, we have already discussed, but I just want to show it to you again. Okay. Yeah. Okay, so,
Yeah, I think it's goodness with
okay,
the
you can remember. So, nitrogen, phosphorus, sulfur, tin, lead, and all transition elements, they can have different oxidation states. Okay, so it will be like case by case. It may differ, right? Okay, let's try out this question and then we'll go to the next question. Next part of the worksheet we are doing. Yeah, please do it for SO3 2 minus. So find the oxidation state of all the elements in SO3 2 minus. Please do it. Meanwhile, anyone who is not understanding, please let me know. Is everyone following? Yes or no? See, if you don't answer, like I have to assume that nobody is following. Are you following?
Yes, miss.
yes.
Thank you.
Yes.
Okay, good. Okay,
Yes.
so yeah, once you're done, let me know. So you have to find the oxidation state of all the elements in SO3 2 minus. Done?
Yep.
Let me know once you're done.
Yes, I finished.
Okay, what did you get?
I got for sulfur I got +6, and for oxygen I got -2.
Correct. Okay, so let's try to see oxygen in most of the cases it is -2, right? So we can take this as -2. Then sulfur, yes, it is variable depending on the compound. So let's assume that sulfur is X. So X plus 3 into -2 is equal to -2, right? So X -6 is equal to -2, right? Okay, then X is equal to how much? -2 plus 6. What's your answer?
I got sulfur as +6 and oxygen as -2.
Okay, so sulfur, see, how do we solve it? So sulfur is X, X plus 3 into -2, and overall charge is -2, right? Because there is a charge here. So the total
Yes.
should add up to this number, right? Do you agree with me or no?
Yes, yes.
So X minus 6 is equal to -2, right? So when 6 goes to the other side, it gets a positive charge. So it will be -2 plus 6, which will be +4. So the answer will be +4 for sulfur.
Okay, I understand.
So where did you go wrong?
I did not put that it equals to -2, and that's where I went wrong.
Oh, okay. Okay. See, so make sure that you remember this. In case there is no charge, then it will be equal to 0. But in case there is a charge, it will be equal to the charge. Clear?
Yes,
Is
I
everyone
understand.
clear with this or no?
Yes.
Okay.
Yes, we
So
are.
please make sure that you remember this. In case there is no charge, it means it will be equal to 0. But in case there is a charge on the ion, has to be equal to the charge. So how do we, so just repeating this one. So sulfur, we assume it as X. So it will be 3 into -2 is equal to -2. That is the charge here. So we solve this equation, we get X is equal to +4. That will be the oxidation state for sulfur, and oxygen is obviously -2. Okay, I think we can go back to our worksheet. Okay. Okay, let's go back to this one. Yeah, so this question is coming definitely, and like it's like level 7 to 8. So please do not lose any marks here. Okay, let's go to the next one. Okay. A student prepares. Okay, I want someone to please read this one. Read out loudly, please. Anyone volunteer? Yes, anyone wants to volunteer to read this question?
A student prepares a solution
Thank
of the
you.
soluble salt lithium sulfate using neutralization reaction between sulfuric acid and alkali lithium hydroxide. To make sure that she obtains a pure solution of the salt, she first carries out the, sorry, miss,
It's okay, it's okay. Okay, go ahead, go ahead, go ahead.
Miss Alex has volunteered to read.
Oh, okay. Okay, half you can read, half Alex can read. Or maybe Alex can read the next question. Yes, go ahead, go ahead. Let's not waste time. Please go ahead. Alex will be reading the next question. Don't worry. Go ahead.
Okay, a student prepares a solution of the soluble salt lithium sulfate using a neutralization reaction between sulfuric acid and the alkali lithium hydroxide. To make sure that she obtains a pure solution of salt, she first carries out a titration to find the volume of sulfuric acid and lithium hydroxide that reacts exactly together. She uses the method in the titration. Use a pipette to add 25 centimeter cube of dilute sulfuric acid to a conical flask. Add a few drops of, miss, I can't pronounce that, indicator. Fill a burette with lithium hydroxide solution and the lithium hydroxide solution from the burette until the indicator just changes color.
Okay, good. Thank you. Okay. So the first question is, name the type of reaction taking place between sulfuric acid and lithium hydroxide. Okay, yes, this is a very easy question. So what is the name of the reaction?
Neutralization.
Yes, what is the name of the reaction? Very good. Acid and a base, so it will be neutralization reaction. Very good. Okay, let's go to the next question. Next question. So it says the diagram shows the burette readings in the experiment before and after adding the lithium hydroxide solution. So use these readings to complete the table, giving all values to the nearest 0.05 cm cube. Yes, please. This is super simple. Please do not lose any marks here. So tell me what will be the answer for this one. So burette reading in cm cube after adding alkali. Yes. Yes. What is the answer for this one? It's super simple, right?
23.60,
Correct.
2.25, 21.35.
Very good. That's right. So 23.60, 2.25, and then 21.35. Correct. Very good. Okay, so now remember this. It has been given that giving all the values to the nearest 0.05 cm cube. It means that your measurements should have at least, not at least, it should have 2 decimal places. Right? So remember this. This is important. Okay, so see, you can write 223.6, but that will not be given marks because it says your value should have 2 decimal places, so it should be 23.60. Is everyone clear? So make sure that you follow, like read the question carefully and answer what is asked. Okay, so it should have 2 decimal places, and then that will be your right answer. Okay, next one. Okay, the student repeats the experiment. Yeah, this is level 5 to 6. The student repeats the experiment using a different concentration of sulfuric acid. The table shows the results. Okay, so identify the titration results to be used by placing ticks in the table where appropriate. Okay, so we are taking only the concordant results. So now what are concordant results? The results are called concordant when these volumes differ from each other by 0.20 cm cube or less. Okay, take 30 seconds, go through this question and then tell me what will be the answer for this one. Okay, take maybe 30 seconds, 1 minute, and tell me what will be the answer for this one. This is super simple, easy marks. So please tell me what will be the answer for these ones. Anyone who does not understand the question? Everyone understand the question or no?
Yeah,
Yes.
is it 23.5 and 23.7?
Okay, yes, correct. That's right. Okay, so see, it says that concordant results are those volumes that differ from each other by 0.20 cm cube or less. Okay, so now see this one and this one, they differ only by 0.20 cm cube, right? So this one will definitely come, this one will definitely come. See, this is no question because like it's like very far away. Then 23.95, it is like it is close to 0.20, but it is having a gap of 0.25 cm cube. So we cannot take this one as well. So we have to take these two numbers, right? Clear with this? So we have to take these two numbers because these are the only ones which are differing by 0.20. Other numbers, they are differing by more than 0.20. That's why we have to take these two numbers only. Okay, understand? These are like easy marks. Don't lose these marks. So what do you have to do is you have to put titration result to be used. You have to put just tick mark here. Okay. Then next question is use the titration results you take then to calculate the average mean volume of alkali added. This is super simple again. These two numbers add and divided by 2. So the answer will be 23.60. Anyone any doubts here?
No.
No, right? It's like super simple. Okay, so don't lose marks here. These are like easy marks. Okay, let's go to the next question. Now, again, level 7 to 8. Yes, these questions may look a little complicated, but they're very simple and you get them and then you get like scored higher. Okay, okay, Alex, I want you to read this question.
Okay. In a titration using solutions of the same acid and alkali, but of different concentrations, she recorded these results. Volume of sulfuric acid is 25 centimeters cubed. Concentration is 0.107 moles / DM3. And the average volume of lithium hydroxide solution is 22.85 centimeters cubed. And then the equation is for that. And then calculate the amount in moles of H2SO4 in 25 centimeters cubed of 0.107 moles / DM3 of sulfuric acid.
Correct. Okay, so now tell me which formula will you use to answer this question, the first question?
Concentrations times volume.
Okay, so there is a formula. Let me write the formula. If you do not know this one, you can write it. So N is equal to CV. Okay, so what is N? N is the number of moles, C is the concentration, V is the volume. Okay, so you can easily use this formula. So if you do not know, please make a note of this. The formula we use is N is equal to CV, where N is the number of moles, C is concentration, and V is volume. And then you can put the values and tell me the answer.
2.675.
Okay, so you have got 2.675. Okay, let me write it here, 2.675. Anybody with some different answer?
I'm still doing it, miss.
Sure, sure. Take a minute, do it. Do you want
0
to? Yes.
0.00268.
Okay, 0.00268. Okay, fine. Anybody with a different answer? Or yeah, I'm like, yeah. I'll give you 30 seconds more. Anybody with a different answer, you can let me know. Or in case you have the same answers, let us take a poll. How many have got which answer and like, yeah. Is everyone done?
Yes.
Okay. Yes. So how many have got the first answer? Or you have a different answer? Let me know the number.
Yeah, I got the first answer, 2.675.
Okay. So two people got this answer. Anybody who got this answer? Yes.
I got the second answer.
Okay. So two people have got the first answer. Two people have got the second answer. What about others? Have you got any other answer or how is it? Okay, let's try to do this one. Okay, people who have not CV, so it's the very common formula you have to use. So calculate the amount of moles, amount in moles of H2SO4 and 25 cm cube of this concentration sulfuric acid. Okay, first thing when you get this question is you have to look at the units. Okay, because of the units, your answer may become wrong, right? So it says 25 cm cube, here it is 0.107 moles per dm cube. See, you can't have different units here, cm cube and dm cube. Understand this? So you have to convert 25 cm cube to dm cube. Understand this?
Yes.
Okay, so what will happen? So when we substitute, it will be 0.107 into, see, our concentration is in moles per dm cube. So our volume also should be in dm cube, not in cm cube. See, remember this, when you're substituting, the volume should be in the same unit. Either you convert cm cube to dm cube or dm cube to cm cube. So in this case, what we can do is it's easier to do this way. So cm cube to dm cube. Now tell me, how do you convert cm cube to dm cube?
You divide it by 1,000.
Correct. Very good. So it will be 25 divided by 1,000. Clear with this? Now you calculate, you will get the right answer. Okay, so I think the first one to tell the answer, like you, I think only did the mistake you did was you did not convert this to dm cube. That's why you got the wrong answer. Okay, so you were on the right track, but you did not see the units. That's why this answer is wrong. This is the correct one. Okay, so remember this. What you have to do is first check the units in which they are given. So 25 cm cube, we'll convert it to dm cube. How do you do it? Divide by 1,000. And then you have to multiply with this concentration, which is 0.107 moles per dm cube, and then you'll get the right answer. Clear with this? Is everyone clear?
Yes.
Okay,
Yeah.
so this will come in exam tomorrow. Please make sure that you don't don't get confused here. Remember this, it's the simple formula, n is equal to cv. Substitute the values. While substituting, make sure that your units are same. So cm cube, you can convert it to dm cube by dividing by 1,000 and then get the answer. Okay, let's go to the next one. Next question is, calculate the amounts in moles of LiOH in the 22.85 cm cube of lithium hydroxide solution. Yes. Okay, please try it out. Try it out. I give you 1 minute. Try it out. Everyone following this or no? See, these questions are coming tomorrow in exam. If you're not clear, please let me know. Nobody is judging you. Okay, so please let me know in case you're not following. I can explain you again. If you do not comment or if you don't say anything, I assume that you are following. Okay.
Yes.
Okay, so calculate the amount in moles of LiOH in the 22.85 cm cube of lithium hydroxide solution. Okay, it's like super simple in case you follow this equation. I'm giving you a hint. It's very simple if you just follow this equation.
Does it have to do with the mole ratio?
Very good. Correct. That's right. It has to do with mole ratio. Correct. So you have to take into consideration the mole ratio of lithium hydroxide and sulfuric acid.
So would the answer be what the answer we got before times 2 because they're in a 2-to-1 ratio?
Correct. That's right. That's correct. Okay. So you can see here, the in the equation we can see lithium hydroxide and sulfuric acid. They are in a ratio of 2:1, right? And you already got the number of moles of sulfuric acid, which is 0.002675. So you can multiply by multiply it by 2, and that will be the answer for moles of LiOH. So what will be your answer? Or when you multiply it by 2, how much do you get?
I got 0.00535.
Correct. Very good. That's the right answer. Okay, good. So that will be equal to 0.00535. Okay, everyone following this? So what we have to do is, in case you know the number of, see, we have calculated in the first part the number of moles of sulfuric acid. Now you can see that the mole ratio between sulfuric acid and LiOH is 2:1. It means that the number of moles of LiOH is double the number of moles of sulfuric acid. So your answer, how you'll get it? You have to multiply this number by 2. So the answer will be 0.00535. Is everyone clear with this or no?
Yes.
Yes.
Okay, let's go to the next question. Next question is, so this is the last question of this worksheet. It says, calculate the concentration in moles per dm cube of LiOH in the lithium hydroxide solution. Now, this is again, you have to use the same formula. N is equal to Cv. Okay, so we use the same formula. N is equal to Cv. So C becomes what? N by V. Yes, please do it. So you have all the values with you. Once you get the answer, please let me know.
I got the answer.
Okay, how much did you get?
I got 4.27.
Okay, let me write it here. 4 point. So you got 4.27 moles per dm cube.
Yes.
Okay. Anybody with a different answer?
Yeah, I got 0.234 moles per decimeter cube.
Okay, 0.234 moles per dm cube. Okay. So this is okay. This one is whose answer?
Mine, Abdullah.
Okay. So 4.27 is whose?
Laura?
Okay, Laura and Adrilla. Okay, fine. Okay, anybody else with any other answer? Okay, I'll give you maybe 1 minute more. 1 minute more. Try it out. Try it out. I want everyone to try it out and then get your answers. You can take one side, you can take Adria's side or Laura's side, or you can have your own side. So let me know. I'll give you 1 more minute.
Miss, it's Abdullah.
Huh? Come again?
My name is Abdullah.
Okay, Adrella.
Abdullah.
Okay, okay. What's the spelling?
Abdulla.
Oh, okay, okay, Abdullah. Okay, okay, sorry, sorry,
Yeah.
sorry. Okay, I heard it wrong. Okay, yeah. Okay, so you can
Miss,
take Laura side or Abdullah side. Yes. What is, yeah, anyone with the
I
different?
sorry, I'm Laura, and I realized I got the answer wrong because I divided the wrong thing. Sorry, I got the answer
Okay.
wrong. Abdullah's wrong.
Okay.
Abdullah's answer is right. Sorry.
Very good. That's right. Well done. Okay, so yeah, now we have only one team. So Abdullah's team is here. So is anyone competing with him or everyone is following, like his answer is correct? Yes,
Yes,
anyone
I
with the
got the same
different?
as Abdullah.
Miss.
Okay, so good. Okay, so we have got the right answer. So how do we do it? So concentration is equal to N by V. So what is number of moles? Number of moles is this one, right? 0.00535, right? So we substitute the value. So it will be 0.00535. And what is the volume? Volume is 22.85 cm cube, right? Now, when we have to convert it to dm cube, we have to divide it by 1000. So this will be 0.00535 divided by 0.2285, right? And then you will get the answer, which is 0.234 moles per dm cube. Are you clear with this or no?
Yes.
Is everyone following this? So
Yes.
Yep.
remember this, it's like very simple. You have to follow the equation N is equal to CV. Definitely one question is coming from here tomorrow. So N is equal to CV, N is number of moles, concentration is C, and V is volume. Remember this, the units have to be same, okay? So you have to convert CM cube to DM cube divided by 1000, okay? And in case you have to convert DM cube to CM cube, multiply by 1000. Okay, so always make sure that the units are same. In case the units are not same, you will get a wrong answer. Is everyone clear with this first worksheet? Yes, anyone wants to like clarify something from this first worksheet or no? Or everyone is like everything is clear? Okay, if you don't answer, I assume that everything is clear and everyone is going to score full marks tomorrow. Okay.
Yes.
Yes. Okay. Okay. So let's go to the second worksheet, which we have. Okay. So I go to second worksheet. Later, like I have made the answer key also for I can share it later. Okay. Let's start with. Can you see my screen by the way?
Yes.
Yes. Okay. So it says state the meaning of the term atomic number. Yes. What is atomic number? Yes. How do you define atomic number? Okay.
You can
See,
find it on the periodic table.
okay. So see the atomic number and the periodic table is depends on what, like how they are arranged.
By the
Is it the
amount.
number of protons?
Correct. Very good. Okay, that's right. So atomic number is basically the number of protons in the nucleus of an atom. So when you define it, like when you have to write the meaning, you have to say that the number of protons, the number of protons in the nucleus of an atom. Okay, so this is the right way to answer this question. Okay, so this is fine. Let's go to the next one. Next question is an atom of element X contains 14 protons, 14 electrons, and 15 neutrons. Which of these is the mass number of this atom? Yes, what is the answer? This is super simple. Don't lose marks here. Yes, what will be the answer for this one?
29.
Correct. So mass number is equal to number of protons plus number of neutrons, which will be equal to 14 plus 15, which is equal to 29. Okay, remember this atomic number is equal to number of protons, which is also equal to number of electrons. Whereas mass number is equal to number of protons plus number of neutrons. So in this case, it will be 14 plus 15. That will be 29. Okay, then outline which group of the periodic table element X belongs to. Yes, which group it will be?
Group 2.
Um,
Mhm.
uh, isn't it group 4?
Okay, let me make a note. Okay. So you have somebody saying group 2, then group 4. Okay, what else?
I agree with group 4.
Okay. Yeah, see group 4 or group 14. Anything is fine. Let me show you the periodic table. So you will have a see. So somebody said group 2. Why did you say group 2?
Because I thought since it had 2 valence electrons, then it's in group 2.
Okay. See, it has got the atomic number. So proton number is 14, right? So it means the atomic number is 14 as well, right? Yes or no? See, the
Sorry?
proton number is 14. So the
Yeah.
atomic number also will be 14, right?
Mm-hmm.
So what will be the electronic configuration? 284, right?
Oh yeah, sorry, my bad.
So 284, right? So it will be like it can be 4 or 14. Okay, so yeah, you can write 4 or 14. That should not be a problem. But let me show you the periodic table. So you're clear with this. So periodic. See, in case this question comes in exam, look at the number of protons, and then from the number of protons, you can know like what is the atomic number of this element, and then from the atomic number, you can always find the group number. So you can see this one. So 14 is silicon, right? So it belongs to this one. Can you see here? So it is 4A or 14. Are you clear with this one? Is everyone
Yes.
clear?
Yes.
So the proton number is, see the number of protons is given as 14. So it means the atomic number is 14. So it will belong to either group 14 or 4A, like anything you can write. It should be fine. Okay,
Yes.
so you're clear with this. Let's go to the next one. Next question is, the table shows the composition of a sample of a different element Y containing 3 isotopes. Okay, so using information from the table, calculate the relative atomic mass of this sample of element Y. Give an answer to an appropriate number of significant figures. Yes, please go ahead and write the answer, like calculate this one. Anyone who does not know how to do this one, let me know. Others, you can try on your own first.
Sorry, miss.
Yes.
I thought the meeting was only going to be an hour, and I have an appointment at 6:45, so I have to go.
Okay, no worries. Who is this actually? Like, who is this?
Alex.
Alex. Okay. No worries. Yeah. See, I think this will be recorded, so you can always check back, like whatever, like the remaining part, you can always check back. Okay.
Okay, thank you so
Okay.
much.
All the best. Do well in the test
Thank
tomorrow. Okay.
you. Thank you. Bye.
Okay. Bye bye. Take care.
Bye.
Anyone who does not follow how to do this one, let me know. Others, I give you some time. Do it and tell me the answer. What do you get?
I got 32.1.
32.1. Very good. Is it Abdullah?
Yes.
Okay, I can. I mean, like, I think your favorite subject is chemistry, right?
No, Mrs. Physics.
Oh, okay. Okay, but you like chemistry as well.
Yeah.
Yeah. Okay, so my prediction was correct that your one of the favorite subject is chemistry. Okay, yes, you are correct. So let's try to answer this one. So how do we? So this question is also coming in an exam tomorrow. Maybe not this sample, but some other sample. But make sure that you remember how to do it. So how do we do this one? So 32 into 95 by 100. So you have to take 32 into 95, right? So this is percentage of isotope in a sample. So this will be 32 into 95 by 100 plus 33 into 0.75 by 100 plus 34 into 4.25 by 100. Okay. If you solve this one, that will give you the answer. Okay, so what you have to do is mass number multiplied by the percentage composition divided by 100, and you add up all the numbers. Whatever you get, add up and you will get the answer. Now, the question is when you add up, you will get 32.09. Okay. Now, the question is Abdullah told us the answer was 32.1. And I will take this as more correct rather than this one. Can you give me a reason for this? Not Abdullah, but somebody else. I want somebody else to be like tell the answer why 32.1 is the more appropriate answer for this one than 32.09.
Because it's rounded to the nearest decimal place and it's less sig figs.
Correct, that's right. Okay, so it says give your answer to an appropriate number of significant figures. Okay, see what is the rule we follow? We try to get the same number of significant figures in the answer as there are in the question. So you can see this one has three significant figures, this also has three, and this one also has three. So our answer also should have three significant figures. If we write this as answer, it has four, but this one has three. So the answer will be 32.1. Clear?
Yes.
Okay, good. Okay, everyone following this or no?
Yeah. Also, Miss, so to get the relative atomic mass, it's with predominantly isotopes, right?
Yes, yes. See, thing is,
Okay.
you can like you can come to know your answer is correct or not. See, you can see 32 is close to 30, like 95%, right? So your answer should lie like near to 32. So your answer should be correct.
Okay, thank you.
Okay, let's go to the next one. So it says the concentration of NaClO in solution of a bleach is found by reacting it with hydrochloric acid. The equation for the reaction is this. An excess of dilute hydrochloric acid is added to 4 cm3 of bleach solution. 60 cm3 of chlorine gas is produced. Okay, please take your time, read through the question, and tell me if you understand this one. If you understand, try to do A and B, and we'll discuss. Is everyone able to follow the question?
Yes.
Okay.
Yes.
Okay, so first part is describe a safety precaution that should be taken when doing this experiment. Yes, what is the safety precaution you should take?
So you should wear protective, like safety wear, like lab coat, goggles, and stuff like that. And
Mhm,
you should also not inhale the fumes because they does create a gas which could
mhm,
be toxic. So
mhm,
either open up a window or have go do the experiment in a ventilated room.
mhm. Correct,
Yeah.
that's right.
Yeah.
Okay, that's correct. Very good, that's right. So chlorine gas is produced, so you have to do the experiment in a fume cupboard. Okay, or and also apart from that, you should wear protective goggles like eye protection should be there and so on, right? So you can write anything out of that. So you can write you can wear eye protection and use fume cupboard. That will be your right answer. Okay, then go to question number B. Please write out question number B. Question number B, first part. Please write out. Once you're done, please let me know the answer. Is anyone done with part one for B?
Yes.
Okay, how much
The
did you get?
answer
Right?
is 0.003.
Okay, so you've got 0.003. Okay, so let me write it here, 0.003, right? Okay, let's wait for others to finish. Anyone with a different answer?
I'm a little confused on how to answer this one.
Okay, no worries, we'll discuss. Anybody else?
Yeah, I think I also went wrong in this one as well.
Okay, no worries, we'll discuss. Anybody else with a different answer or same answer?
It's only us three on the call, apart from you.
Oh, okay. Who are the three remaining now?
Sarah, Abdullah, and Laura.
Okay, so Sarah, okay, Abdul. Okay, fine. That's fine. That's okay. No worries. Okay, let's try to answer this one. So it says 1 mole corresponds to 22. Okay, it says 1 mole corresponds to 22.7 dm cube, right?
Yes.
Okay. Now, so what is the volume of chlorine produced?
60 cm cubed.
Correct, right? So we know that what is the volume of Cl2 produced? So volume of Cl2 produces 60 cm cube. Now 1 mole corresponds to 22.7 dm cube. So X mole corresponds to 60 cm cube. So what will be X? So what is 60 cm cube? You convert it to dm cube. So how do you convert 60 cm cube to dm cube?
We divide by 1,000.
Correct. So basically understand the calculation. So 1 mole corresponds to 22.7 dm cube. So X mole will correspond to 0.060 dm cube. So calculate X. So how do you calculate X?
So you take 0.06 and divide by 22.7.
Yes.
0.22.7.
Yes, correct. Okay, so it's like cross multiplication. So you would have like learned in school as well, like mathematics. So X into 22.7 is equal to 0.060. So X will be equal to 0.060 divided by 22.7. Are you clear with this or no?
Yes.
Clear?
Yes.
So you will get 0.003 moles. Okay, so again, you can write the same number of significant figures you can have in your answer. So it will be 0.003. Okay, good. Okay, let's go to the next one. Next question is determine the amount and moles of NaClO in 4 cm cube of bleach. Yes, what is the amount and moles of NaClO in 4 cm cube of bleach? Please try it out. See, there is a very, very simple way of doing this. So, Abdullah, do you know the simple way of doing this one?
Yes, miss.
Yes, what is your answer for this one?
It's the mole ratio is 1 and 1, so it's just 0.003.
Correct. Very good. Okay. So see, there is an easier way to do this one. So you can see here. See, it says determine the amount and moles of NaClO in 4 cm cube of bleach. Okay. So you can see here in the reaction, the mole ratio of NaClO and HCl is like the mole ratio of NaClO and Cl2 is 1:1, right? So NaCl2 and so this one and Cl2, the mole ratio is 1:1. Do you agree with me? So basically the number of moles also will be same. So the answer for the second part will also be same. So this will also be 0.003. Do you understand this or no?
Yes.
Yes.
So the mole ratio between NaClO and Cl2 is same. So the number of moles will be also same. So the answer will be 0.003. Okay, let's go to the next question. So calculate the concentration in moles per dm cube of the bleach solution. So again, use the same formula n is equal to Cv and find the answer. So make sure that the units are same.
I think the answer is 0.75.
Okay. Okay. 0.75. What are the numbers you have taken? Can you tell me?
So I took the moles that we got from the bleach solution, so 0.03, and
0.003, right? So
yes,
0.003. Okay. Then
yes, and then I divided it by the volume of bleach. But before putting it in, I divided it by 1,000 to get it
mm-hmm,
into the right yeah, and that equal to 0.004.
mm-hmm, that's right.
And so I put that in the calculator and it gave me 0.75.
Okay, that's fine. Yeah, that will be fine then. So 0.75 moles per dm cube will be the answer. Has everyone got the same number?
Yes.
Yeah.
Okay, good. Well done. Okay, let's go to the next part, which is about organic chemistry. So it says, okay, so it's simple. So molecular formula is C2H6. So what will be the name of this compound?
Methane? Oh, yeah. No, ethane, sorry.
Ethane, right? Correct. This is ethane. Okay, so let me write it here. So this is ethane. Then what is the empirical formula of this one? Yes, what is the empirical formula? See, empirical formula is the smallest ratio between the atoms in a compound, right? So what will be the empirical formula of this one? What is the smallest ratio
Um,
of atoms?
I think it's CH 3.
Correct, CH3, right? See, C2H6, right? So what is the smallest ratio between 2 and 6? It is 1 is to 3, right? So it will be CH3. So remember this, what is empirical formula? Empirical formula is the smallest ratio between the atoms in a compound. So this will be CH3. Everyone clear with this? Okay,
Yes.
suppose the compound is C2H4. What is the empirical formula of this compound? Yes. Suppose the compound is C2H4. What will be the empirical formula?
CH2.
Correct, CH2, right? Good. Okay, let's go to displayed formula. What do you mean by displayed formula? Yes, what is displayed formula?
Is this to show the connection between the hydrocarbons?
Yes, correct. Okay, so the
So
displayed formula
it will
basically
be
shows the
two carbon,
mhm,
two carbon single bonds, and then each three hydrogens connected to each carbon with single bonds. Yeah.
correct. Very good. That's right. Okay, so it will show the different atoms and the different bonds. So it should show the like how the atoms are arranged together, right? So this will be the displayed formula. Okay, then next question is complete the chemical equation for the complete combustion of alkane C2H6. Okay, quickly try this one and tell me what is the answer for this one. So you are doing complete combustion. See, when you have complete combustion, you will get the products carbon dioxide and water, right? Okay, try it out and tell me the answer.
I have a question about this one.
Yes.
Are we allowed to have decimals in the when balancing?
See, ideally, don't have decimals. What you can do is, in case you're having decimal, you can multiply the whole thing by 2. So the decimals will be eliminated.
Okay, thank you.
See,
Miss,
sometimes you'll get. Mhm.
so
Yes.
I asked my teacher about this, and she said that when it's oxygen is fine. She didn't go deep into why, but she just said when oxygen is the case, then I think because it's HO2, from what I
Mhm.
understood, because it's a diatomic element, that it's
Mhm.
okay that if there's decimals.
Okay. See, thing is, instead of having decimals, like we can. Okay, so I think you are getting 3.5 here, right? Something like that.
Yes, 3.5. Yeah.
Yeah, 3.5, right? So you're getting 3.5. So ideally, what you can do is you can multiply the whole thing by 2, right? So it will be 7. So the teacher will be looking at what are the coefficients here, right? So here here, here, and here. So it should be balanced. Okay, so ideally, in case I was correcting, I will check like in case everything is balanced. Right, so I will prefer that you
Yes,
multiply
of
the whole
course.
thing by 2, and that will be fine. But in case your teacher has told that she like okay with decimals, then also it should be balanced. Like she should be looking at other coefficient as well. This, and this as well. Okay,
All right, I understand. Thank you.
yeah. But like yeah, in case you have decimals, multiply the whole thing by 2. So like anyway, it will be balanced already. Okay, so yeah, you have got the numbers. What are the numbers you have?
So I put 7, 4, and 6.
Okay. 7, 4. What about 2? 2 here, right?
Oh yeah, sorry. 2, 7, 4, and
Yeah.
6.
So it will be 2, 7, 4, and 6, right? Correct. That's right. Others have got the same numbers?
Yes.
Okay. Let's go to the next one. It says incomplete combustion occurs when the air supply is limited. Give the names of two products of incomplete combustion. So yeah, what are the products of incomplete combustion?
Isn't it carbonate, so CO3 and water?
Uh, See, incomplete combustion will give you carbon monoxide and water.
Yes, sorry.
Okay, so it will be carbon monoxide. So the products of the incomplete combustion will be carbon monoxide and water. Okay, and further, in case there is less amount of oxygen, so you will get carbon and water. Understand this? So you'll have carbon particles and water. Okay, so remember this, complete combustion will give you carbon dioxide and water. Incomplete combustion will give you, like where there is less supply of oxygen, you will get carbon monoxide and water. In case there is further less supply of oxygen, you will get carbon and water. Are you clear with this?
Yes.
Yep.
Okay, let's go to the next one. It says an alkene with molecular formula C4H8 reacts with bromine to form a compound with the formula this. What is the name of this type of reaction? Yes, what is the answer for this one?
Addition.
Correct. Okay, so it's an alkene. See, alkene undergoes addition reaction. Okay, so alkanes undergo substitution reaction, whereas alkenes undergo addition reaction. So the answer will be A, addition reaction. Okay, then next one is draw displayed form for two different alkenes with the molecular formula C4H8. Yeah, try this one out, please. So what are these called as? Two different formulas with the same, two different structural formulas with the same molecular formula? What are these called as?
Alkenes, but one can have, I think, a double bond. So,
Mhm.
but they can be in different placements.
Yes. So what are those called as? What are those structures called as? Isomers, right?
Isomer.
Yeah, these structures are called as isomers. So what are isomers? Isomers are compounds which have different structural formula but same molecular formula. Have you heard this term, isomers?
No, I've never learned that.
Oh, because next question is about them. It says state the term used for compounds with the same molecular formula but different structural formula. So the answer for this one is isomers.
Okay, I understand.
Okay, so isomers means they have the same molecular formula but different structural formula. Yeah, so that's correct that you can have two structures wherein the double bonds they are in different positions. So let's try to draw them. So this is one of them. So it says, so there has to be, okay, so we can put one here. So this will be one of the structures. Okay, so this is one of the structures, and other structures can be like we can change the position of the double bond, right? So this will be like this.
So we can place them randomly just to show difference, right?
Uh, okay, no, it's not random. See, thing is, you have to count from the side where it gets the lowest number. Okay, so it's not
Okay.
random. You have to think. So you have to like you can count from here, one, two. So it's on the first carbon atom. So between first and second carbon,
Yeah.
right? Now you can can, like, now if we place it here, it will be 1, 2, 3. So this is on the second and third
Yeah,
carbon
I
atom.
understand. I understand like when the different carbon placement is different, but from this question, it's asking us to
Yes,
just
yes, definitely. Yes, that's right. That's correct.
okay, yeah, that's just what I was
Okay.
checking.
So have you got these two isomers? So what are these What are these structures? These are called as isomers because they have got the same molecular formula but different structural formula. Okay,
Yes.
so let's go to the next one. So this we have answered. So these are isomers. Okay, this one, this question it says the alkene C3H6 can be polymerized to form the polymer this. Complete the equation for this polymerization reaction. Yes, what do you think? What will be the answer for this one? See, I think some question like this can come in exam tomorrow. So it's like super simple. How do you do it? Just write the same thing, but open up the double bond. Okay. So what do you do? Write the same thing. Just open up the double bond. So same thing you write here. So this will be HCH3. This will be H here. This will be H here. Now the double bond, what you have opened here, put it on the other side. And then put a bracket here and this n will come here. So this is the simple way to answer this one. So what it says is when you have a monomer, it's an alkene. When it turns into a polymer, it will look like this. So basically n number of units of this one, they combine together to form this thing. Are you clear with this? So this question,
Yes.
I think it will come in exam tomorrow. So it's simple. What do? Write the same thing. Instead of this double bond, you put a single bond and then you put those, like you put single bonds on the other sides and put a bracket and put n here. So this will give you
Okay.
the right answer always. Is
I
everyone clear?
understand.
Okay.
Yeah, I understand that, Miss, but so when we get this question, like for polymerization, we never just like add another carbon, like it's just a different way of um showing the molecular structure, correct?
Yes, correct. So basically it says that n number of these many molecules are joining together. So how it will look? It will look like this. Because like see
Okay.
when they say n number, n numbers means it can be 1,000, 10,000, 1 lakh, it can be anything, right? 1 million. So we do not know. So when we write it here, it means that that many number of units are joining together and it will join like this.
Okay.
Miss,
And we
is
have to,
this
and we add the n at the end?
Yes, we have to put n in, it's not at the end, you have to put it here. So this shows that n number of molecules are joined.
Okay.
I have
So
a
this
question.
thing, yes.
Sorry, is this catalytic cracking?
No, this is not catalytic cracking. No, no, no. See, this is polymerization.
Okay, sorry, then I got confused, sorry.
Yeah. See, catalytic cracking is like you from a bigger alkane, you get smaller alkanes and alkenes. It's a mixture of alkanes and alkenes you will get at the end. So there is a question on catalytic cracking also. We'll do it in few minutes. By the way, this is clear or no? This is polymerization reaction of alkenes. Are you clear with this?
Yes.
Yeah, very clear.
Yeah.
Okay, let's go to the next question. So like few more minutes, I think you all may be tired. So few more minutes and we'll be done. So but thank you for being till here. Okay, let's go to the next one. So it says two ways of disposing of polymers such as this are this and this. Discuss the environmental problems caused by these two methods of disposal. Yes, can you quickly tell me what will be the environmental effect of burying them in landfill sites and burying them to release heat energy?
So polypropane is plastic and plastic takes a really long time to dissolve. So
Mhm,
like it takes thousands of years. So
mhm.
the product of polypropane will sit in the landfills for decades.
Correct, that's right. And the landfills will get filled up quickly, right?
Yeah. And
Okay.
also burning them and releasing them will give toxic chemicals to our atmosphere.
Mm-hmm. Yes, correct. Okay, and then apart from that, it says to release heat energy, right? So when you release heat energy, it can cause global warming, right? So global warming, it has
Yes.
all its like other effects. So it can cause maybe like melting of ice caps, rise in the sea levels, change in the weather patterns. So all of this can happen because of this, right? So you can include all those points here. Is everyone clear?
Yes. Yeah.
Okay, let's go to the next one.
Yes.
Next question is explain how crude oil is separated into its fraction by fractional distillation. Yes, so how do you do fractional distillation? What do you do? Like, what will you write here?
I think fractional distillation is with the boiling tube, and
Mhm.
then there's like the thermometer, and it transfers into a beaker, and water can go in and out, and there's like a condenser, and there's like a fractioning column, if I'm how it separates the crude oil, I think.
Okay.
Doesn't
Yeah.
it,
See. Mhm.
sorry, doesn't it separate because of the different temperatures of like the different melting points within the crude oil?
Okay. See, I mean, like both of you are correct, but like not very correct. I mean, like, yeah, you're like on the right path. See, thing is, so when we talk about crude oil and fractional distillation, we generally will not do in a like in a not in a lab scenario as such, but they will be done in a big furnaces. Okay, so maybe like, did you try it in your lab or no?
No, not in my class,
No.
no.
Okay,
No.
see, like when we talk about like crude oil and then the how it is done, we have to take big furnaces. Okay, let me show you like how it is done. Like in case this comes in exam, what you should be writing exactly. So let me open this one. Okay, okay. Yeah. Okay, so how this is done? So this is done. So petroleum is heated into a vapor in the furnace. So there are like big furnaces in which it will be done. Okay, so like in case you have like gallons of oil, it's like it's a very large amount, right? So we can't do in test tubes. So you have to do in a big furnace. So what is the exact procedure? So petroleum is heated into a vapor in the furnace. The vapor is passed into a fractionating column, and the hot vapor cools and condenses as it rises up the column. Okay, but remember this, what is it based on? It is based on the difference in the boiling points. Okay, so the difference in the boiling points is the basic phenomena on which it is based. Okay, then so lighter fractions with lower boiling points are collected at the top of the column as gases, whereas heavier fractions with higher boiling points are collected at the bottom of the column as residue. Are you clear with this or no?
Yes.
Okay, so in case this comes in exam, what you will write is, so fractional distillation is based on difference between the boiling points of the components. So what do you do is, the petroleum is heated into a vapor in the furnace. The vapor is passed into a fractionating column. So this is a fractionating column. So you are heating it in the furnace and passing it through a fractionating column. The hot vapor cools and condenses as it rises up the column. Okay, and then the lighter fractions with lower boiling points collect at the top of the column as gases, and heavier fractions with higher boiling points collect at the bottom of the column as residue. So this is the part what you have to write in your exam. Okay, let's go to the next one. Next question is, give one use of bitumen. Any idea what is the use of bitumen? Yes. See, bitumen is one of the components when we do fractional distillation. So see again, like last worksheet also there was a question on fractional distillation. This worksheet also there is a question on fractional distillation. So definitely there will be a question on fractional distillation tomorrow. So please make sure that you remember it. Do you know the use of bitumen by any chance?
I maybe for
I
like
think it,
road surfacing or something.
Correct, that's right. So it is used for road surfacing and roofing, right? Correct, very good. So please remember that table. I think your teacher has already shared it with you. So please remember the table which has like the number of carbon atoms in each component and then the use. So that will definitely come. Okay, let's go to the next one. So one of the hydrocarbons in crude oil is an alkane with a structural formula like this. Give the name of this alkane. Yeah, what is the name of this alkane? Yes, what is the name?
Peptane, or yeah.
Peptane. Okay, what is the formula of this compound? Can you tell me the formula of the compound?
Because there's 5 carbons, no?
Yes, C5H12, right? And what did you say? Peptane.
I think
Yes.
she meant pentane.
You said, is this the spelling? See, when you have 5 carbons, you have, it is called as pentane, not
Yeah,
peptane.
pentane, yeah.
Yeah,
Okay, so
sorry, that's what I meant.
yeah, okay, so don't write this one. This is wrong. Okay, so this is the right answer. Pentane, okay? So one question on this also is coming. So make sure that you remember, 1 is methane, 2 is ethane, 3 is propane, 4 is butane, 5 is pentane, 6 is hexane, 7 is heptane, 8 is octane, 9 is nonane, and 10 is decane. Okay, so remember this. Then calculate the relative molecular mass of this alkane. Yeah, so this is simple. Calculating the relative molecular mass of this alkane. So you have the formula with you. Calculate the molecular mass. So what will be your answer for this one? Yes, what is the answer for this one? Calculate the relative molecular mass of this alkane.
I'm not too sure for this one.
Okay, Abdullah, you're sure?
Yeah, it's 72.17.
Okay, good. Okay, so how do we calculate the relative molecular mass? So 5 into the molecular mass of carbon, which is 12, right? Plus 12 into molecular mass of hydrogen, which is 1. So you add up the numbers, you get the number that is the relative molecular mass of alkane. So this will be 72. Are you clear with this? Sarah, are you clear?
Yes.
Laura, are you clear?
Yeah. Clear, clear.
Okay, so this can come in exam. So make sure that you remember this. So it will be 5 C5H12. So 5 into molecular mass of carbon, which is 12, plus 12 into molecular mass of hydrogen, which is 1. Add up the numbers, you get 72. Now remember this. When it is said relative, it means it does not have any units. So it will be just a number. See, when they ask you molar mass, it will be grams per mole. But when they ask you relative molecular mass, it will not have any units. It will be just a number. Clear?
Yes.
Okay, let's go to the next question. Catalytic cracking is used to convert long chain alkanes into another short chain alkanes. Give the name of the catalyst and the temperature used in the catalytic cracking. Yes, what is the catalyst and the temperature used?
So the temperature is 600 to 700.
Mhm. Okay, and what is the catalyst? Okay, see, catalyst uses zeolite. Okay, what is zeolite? You can make a note of this. So zeolite is basically a combination of aluminium oxide and silicon oxide. Okay, so this is the combination of catalyst we use. So you can make a note of this. You can remember, this can come in exam. So what is the catalyst? Catalyst is zeolite, and it's a combination of aluminium oxide and silicon oxide. And temperature, see, generally we use it 550 degrees Celsius. Okay, so has your teacher given a different temperature?
Okay.
Like, what is it?
Yeah, for us, because we did this the other day, and she said 600 to 700.
Okay. Yeah, I mean, like generally like we use 550 degrees Celsius, but yeah, like little bit here and there is okay. So that's fine. So you can like write as per your school, like the teachers, what she has told, but around 550 should be fine. And then is she like, has she given the same catalyst or she has given some other catalyst?
No, she said aluminium and silicon. Yeah.
Okay, so you can write zeolite, and then that's a combination of aluminum oxide and silicon oxide. Okay, so let's go to the next one. Okay, now this is catalytic cracking. Okay, so what is catalytic cracking? So basically in this process, what is done is you heat up a alkane, it dissociates or forms smaller alkanes. It's a combination of alkanes and alkenes. Okay, so heat it up, and then it will form smaller alkanes and alkenes. Now it says catalytic cracking also produces alkenes. So decane can undergo cracking to give C4H10 and two different alkenes. Complete the equation for this cracking process. Yes. So what will be the answer for this one? See, like there is no fixed answer for this one. Yes, come again.
C3 H6 on both should.
Okay, you want to write C3H6. Okay, C3H6. Okay. Uh, See, but it says two different alkenes, right? So you can't have both as C3H6.
All right, sorry, I didn't notice that.
See, because like it says two different alkenes, right? That's why, see, the hint you can get is, so In total, you have got C, like 10 carbons and 22 hydrogens. Here you have got 4 carbons and 10 hydrogens. So you're left with how many? 6 carbons and 12 hydrogens, right? So you have to fix, like you have to get a formula which will have only 6. So the total should be 6, right? So 6 can be got how? 2 plus 4 or 3 plus 3, right? So you can have one hydrocarbon which has got 2 carbons and the other has 4 carbons, or you can get 3 carbons and 3 carbons. But you can't put 3 3 because it says 2 different alkenes. So what you have to do is you have to take C2H4 and C3C4H8. Clear with this?
Yep.
Yes.
Okay, so remember this, it's easy. So basically the number of carbon and hydrogen should be same on both the sides, and you can go, like do all the combinations, you will get the right answer. So look carefully, in case it says 2 different alkenes, you can't put the same formula. But in case it says like 2 different molecules, or like it should be fine in case you put 3C3H6. So it's like simple, add up the numbers and just make sure that your additions are correct. Okay, let's go to the next one. Okay. Next question is a few more minutes. I think you are already like, it's okay, right? We can continue for 5 to 6 minutes more.
Yes, of course,
Yep.
Miss.
This is the last question
Yes,
we are
of
doing.
course.
Okay, okay. So it says a teacher prepares the insoluble salt PbR2 by mixing solutions of lead, nitrate, and sodium bromide. Describe what the teacher should do next to obtain a pure dry sample of lead bromide. Yes, what do you think the teacher should do? Yes. Okay, can you tell me the equation for this reaction?
So what the teacher should do is first she should filter the crystals that she obtained, then she
Correct.
should wash them,
Mhm.
and then put them in an oven to dry.
Correct. That's right. That's the
Yeah,
exact
use
process you
the
should do it. Mhm.
which use the
Right.
evaporating
Mhm.
basin.
Yes. Okay. So yeah, in case like she puts in the oven for drying, that should also be fine. I mean, like that's like how the thing water will be removed, and then she'll get the dry sample of lead bromide. Okay, so remember this. So lead bromide, it is solid, right? It separates out. So how do you separate from sodium nitrate? Sodium nitrate is aqueous. Okay, so it's soluble. So what she can do is she can take a filter paper to separate out lead bromide. Okay, then what she can do is she can wash it with water so that she removes all the NaNO3 which is sticking to it. So this will be clean. Okay, then what she can do is she can paper dry it, like she can use a filter paper to dry it and then keep in the oven to get rid of the remaining water. Okay, so if you write this one, this should be good enough for you getting a full mark. Clear?
Yes.
Okay, let's go to the next question. Next question says the teacher then sets up a circuit in a fume cupboard using the pure dry sample of lead bromide. Explain why the lamp does not light when the lead bromide is solid. Yes, what do you think? Why does the lead bromide does not light when the lead bromide is solid?
Um,
Yes. Mm-hmm.
because it's not a liquid, so
Mm-hmm.
it it will not I think something with the molecules.
Okay. Anybody
Um,
else want to try this one?
uh, she's kind of right because they're not able to move. They're held in a lattice.
That's right. Okay, so that's correct. So in solid state, what happens is there are no ions formed, right? So lead bromide in solid form does not form any ions, so it cannot conduct electricity, right? So there are no free moving ions. Okay, remember this, for the electricity to pass through. See, there are two ways of passing electricity or conducting electricity. In metals, it is done by delocalized electrons. In aqueous solutions, it is done by the ions. Okay, in solid lead bromide, there will not be any ions which are like freely able to move, right? That's why it will not be able to conduct electricity. Clear with this one? Okay, so what you will write is lead bromide in solid form does not form any ions which can freely move, so it will not be able to conduct electricity, so the bulb will not glow, or yeah, the lamp does not light up. Are you clear with this?
Yes.
Okay,
Yep.
let's go to the next question. It says, when the lead bromide is molten, the lamp lights and bromine forms at the positive electrode. State what observation would be made at the positive electrode. Yes, try out this one. So let me write the equation for this one. Like what will be the equation happening here? So you have got PbBr2. Okay, it will form Pb2 plus 2Br minus, right? So this is PbR2. This is in molten state, so it is liquid. Pb2 plus liquid and 2Br minus, right? Okay. Now tell me, so this Pb2 plus will go where? It will go to the anode or cathode? So in your school, have you discussed positive electrode, negative electrode, or anode or cathode? Yes, Abdullah, have you discussed positive electrode or anode and cathode?
Miss, can you repeat the question? I didn't understand.
My question is, in your school, have you discussed about anode and cathode or only positive and negative electrode?
No, we did discuss about anode and cathode.
Oh, you know, okay, fine, that's fine. Okay, so my question is, when we pass electricity through PbBr2, this reaction happens, right? Now, Pb2 plus will go to which electrode and Br minus will go to which electrode?
So the bromide ions are negative, so that it will go to the positive electrode,
Huh?
and the sorry,
Yeah, that's right.
and at the electrode, bromide ions lose like one electron, and the two bromine atoms bond together by sharing.
That's right. Mhm.
Yeah.
That's correct. That's correct. And so, Sarah, what about the Pb2 plus? Sarah is here, right?
Yeah. Yeah. I'm not too sure with this one.
Okay, no problem. We'll discuss that. Okay, by the way, so Sarah, Abdullah, Laura, and who else is here?
That's just us, miss.
Oh, these three. Okay, fine. Okay, so we have got PbR2. It forms Pb2 plus and 2Br minus. Now remember this. Uh, Positive will be attracted to negative, negative will be attracted to positive, right? So that is very simple. So we have got lead 2 plus, it is positively charged, it is a cation, right? It will be attracted to the negative electrode. Now negative electrode is called as a cathode. Are you clear with this?
Yes.
Okay, remember this. Positive ions are attracted to the negative cathode, negative electrode. Negative ions are attracted to the positive electrode. So Pb2 plus is a positive ion. It will be attracted to the negative electrode, which is called as cathode, right? And Br minus, it's a negative ion. It will be attracted to the positive electrode, which is called as the anode. Okay, now let's see what happens at these two electrodes. Now, what will happen at anode? So let me write it here. At anode, these bromine ions, they will come here and they will form, so they will lose electrons. They will undergo oxidation and they will form bromine gas. Like not bromine, it will be bromine liquid, not gas, but bromine liquid plus 2 electrons. Okay, remember this. At anode, oxidation will happen. So two bromine ions, they will lose electrons and they will form bromine and 2 electrons. Remember this, you know, like have you discussed an ox? So anode and oxidation. Have you discussed this or no? Like to remember, at anode oxidation happens, so NOx. So oxidation happens means loss of electrons. So two bromine ions, they will lose electrons, they will form bromine molecule and 2 electrons. Are you clear with this or no?
Yes.
Okay, so remember this, at anode oxidation happens. Oxidation is loss of electrons. So two bromine ions, they will lose electrons, they will form bromine liquid. Clear? And then we have got at cathode. Cathode is negatively charged. Okay, now remember this like red cat. So reduction at cathode. So at cathode, reduction happens. So basically, Pb2 plus, which are positively charged, they will come to cathode, okay, and they will accept electrons. So they will undergo reduction. So it will form Pb. Are you clear with this or no?
Yes.
Yes.
Okay, so understand this. At anode, oxidation happens. Oxidation means loss of electrons. At cathode, it is reduction happening. So reduction is accepting of electrons. So 2Br minus forms Br2 plus 2E minus, and at cathode, Pb2 plus 2E minus gives you Pb. Okay, so this is what is happening here. Now the question here is, state what observation would be made at the positive electrode. So what you can see is brown liquid with a strong smell of bromine produced at the anode. Okay, so you can see at the anode what is happening. Anode is the positive electrode. So there will be a brown color liquid forming at the anode. So bromine is brown in color. So you can see at the anode, brown color liquid is being formed and there is a strong smell of bromine. So that will be your answer for this question. Are you clear with this or no? So it says, state what observation would be made at the positive electrode. You can see that at the positive electrode, bromine is being formed. So what will be the observation? See, when they ask you observation, it means that it should be visually you can see, right? So what you will see is there is a brown liquid coming up, and then there is a smell also coming up, like which is of bromine. Clear with
Um,
this?
I don't understand how you got there would be a brown observation. Can you just repeat
Okay.
that, please?
Yes, sure. Okay, so are you clear with this that at anode Br2 will be formed? Yes or no?
Yeah.
Now, see, bromine has a peculiar brown color. That's why, like, you can see a brown liquid coming up there.
Okay, I guess. Yeah.
Okay, so you have to remember that, like, bromine will give a brown color. So, yeah, I mean, like, some things you have to remember, and then based on that, you have to answer. For example, suppose copper is being produced. Okay, so copper is being produced. So copper will be a pinkish brown color. Okay, so like
Okay.
every like component will have a different color. So bromine will give a brown color and it will give a smell also, which will be like a pungent smell. So you can write these observations. Clear?
Yeah.
Okay.
Thank you.
The next one, explain how bromide ions in the molten lead bromide become bromine molecules at the positive electrode. So you can write that they undergo oxidation. So you can write this reaction. So two bromine ions, they undergo oxidation and they form bromine molecules. And you can write this reaction. That will be the answer for this question. Clear with this? Are you clear or no?
Yes.
Yeah.
Okay. Then next one, write an ionic half equation for the reaction that occurs at the negative electrode. Include state symbols in your equation. So for this one, it will be this one. Okay, so negative electrode is cathode. So you have to write Pb2 plus to form Pb liquid. So that will be the answer for this question. Are you clear?
Yeah.
Yeah.
So Sarah, Laura, Abdullah, any doubts? Like any small, big, any doubts, or you are very clear?
No, everything is really
No, I
clear.
think we went over it in the call. I think it was very thorough. Thank you so much. It was
Yep.
Okay, my
very good.
pleasure.
Thank
Thank you
you.
so much. I really appreciate it.
Thank you,
Yeah.
thank you, and I wish you all the best. Like do very well. Okay, and like you can comment like once your exam is over, let me know how it went, and it will be good for like yeah, I'll be happy to know like it went well. Okay,
Of course, Miss. Yes. Thank you so
Thank you
much.
okay,
so
all the
much.
best. Do very well.
Thank you.
Thank
You
you.
too. Have a nice
Okay,
night.
bye. Take care.
Thank